in this question, we have two objects, one of 0.45 kilogram and one that is 0.9 kilogram. So these two objects, two hockey pucks, that hit each other. Let's call this one object A. So this moves at a speed of 5.8 meters per second towards east, which we can define as positive. And it hits this object B, which is initially at rest, as they undergo a perfectly elastic collision. We're asked to find what is its direction and speed of the object after the collision. So firstly, let's do a little bit review of section 7.4 and 7.5. What we learned is that for any elastic collision, we have conservation of kinetic energy and conservation of momentum. So we can write down two equations, one for conservation of kinetic energy and one for conservation of momentum. Or another thing we can do is we can write down the conservation of momentum this is conservation of momentum plus another equation, that is equation 7.7. We can use this equation in place of the kinetic energy equation because it's easier to deal with, it's linear, there's no quadratic terms, and this equation is actually derived from the combination of kinetic energy equation and the momentum equation. So having these two equations is actually a much easier way to solve all collision problems. This is equation 7.7 and a very useful equation. It only applies for 1D elastic collision. So let's start with these two equations. Firstly, we see that VB, object B, is initially at rest. So we can cancel these two terms. Now what we have is, in this equation, we have VA prime in terms of VA and VB, and that's great. VB prime, sorry. We have VA prime in terms of VA and VB prime. So we can use this to cancel a dependence of either VA prime or VB prime in this equation. Let's do VB prime equals VA plus VA prime. This is just what is derived from this equation if we rearrange it. And if let's call this equation 3. This is equation 1 and equation 2. And if we plug equation 3 into equation 1, then we can replace all the VB prime by VA and VA prime. So we can cancel VB prime into these equations. Then the only unknown in this equation will be VA prime. So let's do that. So then we have MVA equals MA VA prime plus MB VA plus VA prime. And that, if with a little bit rearrangement, we have VA prime equals MA minus MB over MA plus MB times VA. If we just plug in the numbers, MA is lighter than MB, so this is a negative number. And it's 1.75 kilogram in the denominator times 5.8 meters per second gives us negative 1.93 meters per second. So this is a negative number, meaning part A will actually move in the opposite direction that it comes from. So from the conservation of momentum, we can guess that B will move this way, so that the sum of it is still going rightwards or going east. So we should expect VB prime to be positive, and we see that it is indeed a positive number because VB prime equals VA plus VA prime, which is negative 1.93 meters per second plus 5.8 meters per second. And that gives us 3.87 meters per second. And this is going west because we define east to be positive, and this is going east. So that is the direction and velocity of the two objects after the elastic collision.